So per usual with most live stream webinars, presentations, whatever it is, there's always some type of technical difficulty. Today, I guess there is an issue with Google Hangouts, which is what we typically use to as the video streamer for our YouTube live sessions. There's an issue and it's not working for a lot of people, including us. So we're starting a little bit late, about 10 minutes late, but we're still going to do a LoRa-based session and answer any and all questions that come up and that you guys have. And we do have our resident LoRa expert here in the office, which I'd like to introduce. His name is Brian. So Brian, why don't you step on into the video feed here? So Brian is our business development manager here at myDevices, and he's been talking with many different LoRa manufacturers. He's flying. Where'd you last come from?
Seoul, Korea.
Seoul. So he was in Korea at a big LoRa conference. He's going all over the U.S. talking to different LoRa manufacturers. And so today, what I'd like to do is I have specific questions that I'm going to pick his brain with, and I want you guys to ask your own questions as well. Anything about the LPWAN space, the LoRa space, we'll be able to answer, and if we can't answer, we'll get you the information that you're wanting. Before we get started, I think it would be good to kind of give an overview, Brian, of, first of all, at least how I understand, LoRa is just a sphere within a bigger space, within the LPWAN space. Can you talk a little bit about what is LPWAN and why is it, I guess, becoming prevalent in IoT?
Yeah. So, should I talk to you or should I talk to
both?
I don't know. I'm not.
Talk to them.
All right, great. So LPWAN, right? Low power wide area networks, is kind of what we're counting on, what the industry is counting on to really make IoT possible. I'm sure everyone knew that. So sorry if some of this is review, but so the technologies are structured in such a way that they're passing very little amounts of data. Because if you think of most use cases in the Internet of Things, sensors measuring temperature, motion, those sort of things, it doesn't require a constant connection in order for a device to send that data. It's not a large amount of data. So the premise of LPWAN technologies is these are devices that wake up periodically to send their data to some sort of gateway or aggregating device. And because they're sending such little data so infrequently, they can run on batteries for many of them for many years at a time.
Got it.
You could place sensors all over whatever, let's say if you had an agricultural use case, you have sensors all over the field and you kind of set them and forget them, and then collect your data.
Okay.
So LoRa is one of the technologies that's emerged in the LPWAN space, and not just the LPWAN space. I'll kind of get into, there's a distinction between LoRa technology and LoRa WAN.
Okay, and maybe you mentioned this. What does LPWAN actually stand for?
Low power wide area network.
Low power wide area network. Okay.
Yeah.
Got it.
So
and guys, if you're just joining now and you have questions, go ahead and post them in the chat. We'll definitely answer them. So Javier Chan, I'm glad you're ready to rumble. We're ready to rumble too. Ron, we're glad to know we're also not the only ones technically challenged. So yeah, ask your questions. We're going to continue talking about the LPWAN space, how LoRa is involved in it, and ask us your questions. So sorry, Brian, I interrupted. You were talking about, I guess, kind of just touching on LoRa.
Yeah. So LoRa is a type of low power wide area technology. Oh, by the way, I didn't say, but the wide area network portion is, again, because this is very small data rate, or very small data amount, it's able to be sent over long distances. So
Got
when
it.
you think of, Wi-Fi having, the constraints that we're kind of all familiar with Wi-Fi.
Yeah.
LoRa range tests have shown data being sent, close to 10 miles line of sight.
Wow.
So it becomes a lower cost solution because you only need to have a gateway collecting that data, periodically throughout whatever space you're in. So yeah, less gateways means that this is a lower cost solution.
Got it. So you said 10 miles of range?
I mean, that's clear day, line of sight. You got a gateway on top of a tower or a mountain, and streaming down to sensors. But yeah, I know there have been even higher range tests.
Yeah.
I think it's kind of expected if you're in a regular environment, with obstructions and trees and such.
Like buildings or walls or whatever.
Yeah, I mean buildings and walls. It depends on what your building's made of, but you could potentially cover an entire building with one or two gateways. And that's like pretty complete coverage indoors.
Got it.
Maybe there's some basement or somewhere that's not getting reception, but the gateways and the devices keep getting developed in such a way that it's just going to improve coverage.
Okay. So because I have a bunch of LoRa questions because I'm not really that familiar as I'd like to be with LoRa specific technology, and I know you really are. So there's the LPWAN space, which is kind of a big space, and LoRa is one player in the LPWAN space.
Yep.
Can you just briefly touch on maybe some other players before we go and dive into LoRa? Because from what I understand, LoRa is just one player within this giant kind of new space of low power wide area networks.
Sure. I know there are many smaller players as well, but I'll kind of touch on the other two big ones. And that's, I'm sure you've heard of Sigfox.
Yeah, I've heard of Sigfox.
Sigfox, I'm not sure historically if they kind of started the LPWAN revolution, but they're definitely the most prevalent player, especially currently in Europe, where they're headquartered, where they began. But now they've moved into plenty of other countries, including the U.S.
Yeah.
So Sigfox, the way that I like to think about it is, LoRa is that technology is getting propagated by an alliance. It's an open alliance, and there are many partner companies who are doing various parts of the LoRa stack. So and much the way that Wi-Fi got disseminated and developed through an alliance. Sigfox is kind of like the Apple of the LPWAN space. They don't have an ecosystem of other companies. They kind of control their whole stack and do everything in house.
Okay.
And then there's a third company called Ingenu, or it's spelled like Ingenue, but so Ingenu, they have kind of their unique flavor of LPWAN. They're using a radio frequency that's worldwide, that's used worldwide. So whereas with Sigfox and LoRa, they actually need to alter what channel they're using based on their country location.
Got it.
Ingenu chose a widely used band and kind of tweaked their technology in order to minimize interference.
So that kind of touches on something that I'm not too familiar with. Is I assume that there's a band or a frequency for LoRa devices, and is that the same band that like my cell phone's on, or some other radio frequency? Are these specifically saved for LoRa devices, these bands?
Yeah, it's a great question. So for LoRa, they're actually using an unlicensed frequency. So whereas for your cell phone and other devices, those are licensed frequencies that are paid for by the cellular companies. LoRa is using an open, unlicensed frequency. So technically, anyone with an FCC certified any type of device could be communicating over this frequency.
Got it.
But what makes LoRa technology unique is they utilize something called a spread spectrum. Radio spread spectrum. So they're actually spreading out those messages over several frequencies within a short range. So like if you, 900 megahertz to 915 megahertz, and the message is being split up across those frequencies depending on what the noise in each of them looks like, and the message is actually getting kind of pieced together by the gateway, so that minimizes interference and allows LoRa to communicate on this open frequency without running the risk of having all this interference.
Okay. And is it the same frequency across the world?
It is not. So because of different government regulations, it's a different frequency in the Americas than it is in the Europe region, and different frequency in Asia as well.
So if let's pretend I am an engineer or developer and I'm trying to get familiar with LoRa, what would be some steps that I would do to maybe get started? I guess one would be figuring out what frequency that I need to be on.
Yeah.
Two might be actually acquiring the hardware and then configuring the hardware to communicate through the frequency. So how would I do that? I know if I were, for instance, if I were building a solution that goes over satellite, I'd probably contact some cellular provider. Like here in the US, there's AT&T, Verizon, Sprint, T-Mobile. Are there those same providers for LoRa? Are there people who are ready to accept my devices and transport the data that they're sending across LoRa networks?
So I think there were kind of two questions in there, because you were asking one about the hardware side and then two about the communication side.
Correct.
All right, so I'll start with the hardware side, and kind of to flesh that out, I'll go from the chip setup. So LoRa as a technology, as a radio frequency technology, was started by a company called Semtech, which is actually headquartered close by us here in Camarillo.
Okay.
So Semtech makes the chipset that enables LoRa communication. So both on the device side and on the gateway receiving side. At some point, if someone is building a new LoRa product, they might have, especially if they're going to commercialize a large number, then they might have some interaction with Semtech. Now there are other companies who have licensed the technology from Semtech, and they've made modules. So much like your Wi-Fi shield or your cellular hat, like you could get a LoRa module.
Okay. So there is hardware that is readily available if I wanted to start experimenting in the LoRa space. All I would need is, like you said, an Uno or maybe a Pi, like a Raspberry Pi, and then some type of module that would go on top of that would be able to communicate whatever data I'm trying to send over to some gateway, or is that the LoRa gateway?
No, that would be for your end node. That would be the device that you're building.
Okay. And before we go on to LoRa networks, I think that kind of touches another important aspect of LoRa, is this idea of end nodes and gateways. Can you expand a little bit about the relationship between LoRa end nodes and LoRa gateways? Is it a one-to-one relationship? Can you have a ton of end nodes, or how many gateways are needed?
So again, good question. Since those devices in the field are battery operated, since the end nodes are just sending a little bit of data and waking up, right? They don't have the strength to send it directly to the cloud. So they need to go through what's akin to like a modem or a router. They need to go through this gateway. It's also sometimes called a conduit. The reason it's called a conduit sometimes is because the gateway is actually really dumb. All its job is to do is to listen for and collect the data from any end node that's transmitting using LoRa radio frequency, collect that data and then pass it to some network server, which we'll get into. But so the gateway, there's no intelligence on the gateway. It's just collecting the data, sending it to the cloud.
So it doesn't even care if I have a LoRa end node that I've created, and I know my friend or whoever has a gateway half a mile away. I could create a LoRa end node device, and it should automatically communicate with that gateway and pick it up if it's on the same frequency.
If it's configured, correctly for that gateway, and that's when you get into LoRa networks, because there is ways using LoRa technology. Obviously, if you were some company and you were building a local system, you wouldn't want people's end nodes half a mile away, taking up the bandwidth of your gateways. So there are ways to keep that kind of closed, and there are ways to open it up for people.
Okay.
And that's when we get into the network server side of.
Okay. Now before we get into network servers, we did have a question from greetings from Budapest. Hello out there. Ian Zahn, good to see you. Glad you could join. From Delano Tio, and he's asking, what is the best example about LoRa in a real case scenario? And I know you've been talking with various manufacturers, you've done different use cases. Can you give us an example of a real use case that has either been implemented or perhaps is being implemented?
Gosh, that's a good question, because now I have to think about who we're under NDA with. We can't talk about top secret things. The ecosystem is still young and being formed.
The LoRa ecosystem.
Yeah.
Okay.
So, as far as huge use cases, I know that there's been a lot. I think most of the successful stuff so far has been in the ag space, monitoring soil moisture in agricultural fields, maybe in vineyards, monitoring moisture or nutrients along a vine. That seems to be where, because it's such a slam dunk fit for LoRa technology, right? You put one gateway on a silo, and that can communicate with thousands of end nodes that are out in the field.
And I imagine, at least I'm envisioning a typical agricultural field is just flat, it's barren, there's not buildings. So if you have a tall tower that's sitting, it can probably cover miles of distance, and now any end node that you place in that agricultural field now automatically communicates to that end node, or excuse me, that gateway.
Yeah.
And that gateway relays data to wherever you're displaying it.
Yes.
Got it. Okay.
Yeah. So ag cases are, I think, the first ones that are really becoming popular. You could do an internet search for LoRa use cases, and I think you'll see some of the deployments that have happened.
Okay.
Situations like smart parking, that's another one that's being, I think, widely explored right now. There's been a lot of temperature monitoring in various conditions, whether that's indoor or outdoor temperature monitoring.
Okay. There's another question here from Carlos. What is the advantage of using each user Wi-Fi gateway versus a LoRa gateway for the neighborhood?
That's cool. Someday there will likely be LoRa gateways that cover cities and neighborhoods. I know that there are several companies that are working on deployments like that. Let's see. Disadvantage or advantage of Wi-Fi is the bandwidth and the data rate, right? So you can stream video, and you can those things that just require more bandwidth and a constant connection. But there are neighborhood LoRa initiatives for kind of smart neighborhoods. Where it just takes maybe one person to put a gateway up top, and then if people in the neighborhood have LoRa devices, they could all piggyback.
And actually, Carlos, I can also kind of answer this too. So at least for Wi-Fi technology, typically a device that's on Wi-Fi is going to need ample access to power. So it's going to be plugged into an outlet, or the battery is only going to last like a day or two if it's communicating over Wi-Fi, because typically, at least in my experience and a lot of the projects that I've seen that Cayenne users have submitted, is it's constantly sending data over Wi-Fi. Now with LoRa, if we were to do like a LoRa gateway across a neighborhood, you could use a temperature sensor inside of your house and not change that battery for 5 years, because that LoRa sensor would wake up at a specified interval, right? So maybe it wakes up every whatever it is. So I think a big advantage or difference between if you were to set up a neighborhood that's connected through Wi-Fi versus a neighborhood that's connected to LoRa is power constraint, because LoRa devices, they are meant to be low power and long range. That's actually, I don't know if we've said that, but that's what LoRa stands for, is long range I guess that, I don't know where the low power comes in, but
Yeah,
it's in there somewhere.
It's mostly long range, but
yeah.
Low power is understood.
And another question, William Bello. Good to see you, my friend. How does LoRa handle RF congestion?
Yeah, and that's this goes maybe a layer that's too technically deep for me on the business side, but it has to do with that spread spectrum and how the packet is being sent. So it's somehow staying kind of like what I've seen in presentations. It's like below the noise floor. It's also there are within the technology stack, there's a way of dealing with packet loss or redundant packages. So
packet loss being like if I send data and it doesn't quite get there?
It doesn't quite get there, yeah. So some devices, if that happens, there's and the packet hasn't been acknowledged, it'll transmit again, until it actually knows that a package got through. Sometimes there's so much congestion that a packet might get dropped, but it's a very low rate of packet loss, and the technology accommodates it. So William, I wish I could say more about that, but it has to do with how that message is broken up and sent.
And here's a question I had. So typically when you're like sending data from a sensor to a gateway, there's sort of a response that you'll get back where some end node will send a piece of data, and then that wherever they sent, a response is sent back that says, we got the data, everything's okay. With LoRa, is there a response that gets sent back that says that where the gateway tells the end node, we've received this data?
There can be, and it depends on what your use case is or what your device is doing. Obviously, if that device has to transmit and then listen for an acknowledgement, that's more time that's on, that's more battery being drained, right?
Yeah.
So you can set a LoRa device to, if it's absolutely critical that packet gets through, then you can set a LoRa device to listen and keep transmitting until it gets the acknowledge back. Or in most use cases right now for LoRa, it's just like a send and forget. The device wakes up, it transmits, it goes back to sleep. Whether that packet got received or not, it's probably not mission critical. So maybe the packet for that that 10-minute interval didn't get received, but the next one did. Yeah, the next one will.
Got it. We have a question from Ron Riggs as well. Excuse me. He's asking, what is driving the interest in LoRa? And he goes on, low power or cost or security. From a security perspective, Ron is thinking of things like remote cameras hacked, affecting a DDoS attack.
Yeah.
So I'll repeat the question. What is driving the interest in LoRa? Is it low power? Is it the cost? Is it the security?
It is all of those things. And that's what's making it such an attractive technology. So it is the low power, the battery life, right? Super attractive.
And that's across the board for LoRa technology, LoRa devices. They're all known to have this low power, at least to some extent. I'm sure that varies from a year to 5 years to 10 years, but they're all low power.
Yes.
Okay.
Yeah. So the low power is one. The wide area, the range, is another one. Given what frequency they're using, how they're sending the data, range is a huge thing. Security. So there's a whole team, there's a whole committee in the LoRa Alliance that is devoted to securing the LoRa specification, and so I don't know all the technical terms for it, but basically the data is encrypted from when it leaves the device all the way to when it reaches the application, when it reaches us.
Like a Cayenne.
Like a Cayenne, yeah.
Got it. So from the end node to the gateway, from the gateway to whatever, the network server, and from the network server to the application, everything's encrypted.
Yep. No one, even if someone was able to get access to that data, they have no idea, what it is.
Okay.
But then there's multiple protections against hacks and So if you look up the security protocol for the LoRa WAN spec, it's really in depth, and the committee is top engineer minds in radio frequency space
Mhm.
have really thought out how to make this technology.
Yeah.
So I went to a conference room and we're apparently getting a conference call. Wait, people can call in now?
We're taking your calls.
That's awesome.
So I guess that covered the low power.
Yeah.
Now cost. Here's a question about cost, because I personally, being a product manager here at Cayenne, I've really looked into pursuing different LoRa use cases and things, and I was actually surprised at the current cost it would take to build something. We're talking at least hundreds of dollars, if not thousands of dollars, to build a simple soil moisture use case. So can you give a little bit more about the current cost, and is it eventually going to be driven down?
Yeah, so great point. Again, because the ecosystem is growing, there's not a lot of competition, and the first companies to market have been able to set their price point where they want to. Competition is growing, price is going to go down, cost of the modules is going to go down. I mean, all of those things, it's just, I wouldn't say it's in its infancy. It's becoming a mature technology, but it's still at a point on the business side where costs are still higher than they will be.
Got it. So it's just a matter of time before
it's just a matter of time.
You're going to get a $50 LoRa gateway, and then the end nodes are going to be a few dollars.
Absolutely, and Semtech's going to keep making the chipset smaller, faster, cheaper.
Yeah. Okay. Thank you for your question, Ron. If we didn't answer it to your full expectations, go ahead and ask another one. We're happy to answer them.
Yeah, something I want to distinguish now. I don't know if anyone asked, but LoRa as a technology can be used. Well, actually, we haven't talked about the wide area network, the network server piece of it.
Yes, well, let's get into that.
Okay, cool. Yeah. So, you've got these end nodes, thousands of end nodes, and they're sending, all sending data to a gateway or a series of gateway that would make up a network. Now, what happens to the data next? Well, in a LoRa WAN ecosystem, sorry, I overused that word. But in a LoRa WAN situation,
it makes you sound really smart.
Yeah, the first time I say it, but then when I say it like 9 times, I don't have a vocabulary. So in a LoRa WAN situation, those gateways are then sending their data to a network server.
Got it.
And this is cloud-based software that is routing that data, collecting it, making sure that's going to the customers that it needs to, because you can imagine, you have many different customers possibly on a LoRa network. So the network server is kind of the brains that then takes the dumb data off the gateway and knows what to do with it and where to put it and who the data belongs to. So there are several network server companies that specialize in that software layer, or middleware layer, I guess I should call it. And that would be like companies like Actility, Senate, Laureate, and Things Network, or BeWise.
And those, at least those, Actility, Senate, Laureate, just for everyone watching, Cayenne is actually directly integrated with those networks. So if you are trying to do a LoRa solution, we have great documentation on actually going from literally beginning where you have the hardware all the way from setting up to the gateway, connecting to the network server, and then pushing that data somewhere like a Cayenne IoT project builder. So we'll cover that later. Sorry to interrupt.
Yeah, and I'd love to say a little bit about kind of getting started in LoRa, where to start. So let's keep that in mind. So then those network servers, there are portals that customers can log into to manage the devices, their LoRa devices, and point the data where they want it to go. So currently the way it's set up is data goes from end node to gateway, multiple end nodes into several gateways. Those gateways then send their data to network servers then distribute that data where it needs to go. And Cayenne, myDevices is an option for those where those network servers could point their data to.
Got it. Okay. Now, how many network servers are there? I imagine, at least in my mind, I always like to kind of compare what I know to something that's new. So I'm thinking of these network servers as like a cellular provider, like a T-Mobile or an AT&T, where I can go and I can pick whatever provider I want to use, and then that provider, if I pick, you mentioned Actility, if I would pick Actility and then they would send data, my data, wherever I would want it to go.
Yeah. So there's a finite amount of network servers, like your Verizon, AT&T, like there are players that are emerging as that's their specialty and that's what they're doing.
Okay.
There are also other companies that are working the network server portion into their portion of the technology stack. So, or the technology chain. So, for instance, there are companies that are putting a network server in their gateway, so they can run kind of a local network without having to send data up to the cloud. So that would be for a specific set of use cases.
Yeah.
There are also network servers that are building networks, like physically putting gateways out in cities. So a company like Senet that is a network server is also setting up the network.
Got it.
So like with any, I think, kind of open ecosystem technology, there are some companies that just want to focus on one piece. Like us, we are just that application layer at the end. But then there are other companies who are trying to build the whole thing. They're building devices, gateways, network server software.
Wow, that seems like an endeavor.
It's a real endeavor, and it's again using the Apple model, it might be really beneficial to them, but it was designed that everyone would specialize on their on their section of it.
So for those who are watching right now, I drew a picture while I was listening to Brian talk, and this is kind of how I would envision it or imagine it, where it's the end nodes, there's a ton of them, there's thousands of them, and they're all communicating through at least one gateway.
You want to hold up the camera?
Oh, is it not there?
Oh, are we on this camera?
Yeah, we're on this one.
We're on that camera.
And they're all communicating through a gateway, and now you're sending data from all these end nodes to the gateway, you're sending it to a network server, and then you're ultimately sending it to wherever you want to display it. So that's my pretty picture for everyone here. Now, Brian, you mentioned something that I didn't even think about, and that I think a lot of our users might be interested in, especially when we're talking about there's this huge fear of the cloud and my data is not safe and things like that. It actually just turned daylight here. So, so you mentioned that you could actually put a network server directly on the gateway, and it doesn't have to go to any cloud whatsoever. Is that true? And
yeah,
can you talk a little bit more about that?
Yeah, so that would be called like a LoRa LAN solution, like a local local area network, right? And that's got specific use cases. Maybe you're in you've rigged up your building with LoRa sensors, and you just want to keep all the data local, and maybe you have some firewall. I mean, it's there'd be reasons that would be driving that choice. But the way that the technology is designed is you could go that option. Data doesn't have to go out to a cloud-based network server. Yeah.
Okay, interesting. So one thing that I'll do, as Kevin suggested, is I'll draw this little diagram here that I created on the board behind me, just so to kind of explain. And maybe while I'm doing that, you can just very briefly give an overview of end nodes connecting to a gateway, and then kind of a data stream flow of, I have temperature data, how does it ultimately display on my phone or in some dashboard? And I'll go ahead and draw it.
Yeah, great. So talking about the data flow, and this, again, some of this will be review. So we're starting with the end nodes. End nodes are collecting data from their sensors, and then using that LoRa module, they're now transmitting that data. That data is then picked up by the gateways that are out in the field, or maybe it's gateways set up over a city that's covering the city with LoRa, with a LoRa network. So the gateways are then hearing the data. Now, something we didn't talk about is data sent by a single sensor could be heard by multiple gateways. And
oh, really?
Yes. Yeah.
So we could have multiple gateways over here, up there.
Yep. And they could be they could all be hearing some of the data transmission from from the same end node, then it's up to the network server side is going to stop redundant data. You know, or maybe, oh gosh.
Well, so here's a question: does my end node is it proximity? Why it would communicate to one gateway over the other?
Yes, and I can't remember if the gateways have this built into them, but I think the gateway, I think it is on the gateway, is able to listen for if there's a network of gateways, the one that's getting the strongest signal strength from that device is the one that's ultimately going to pass that data along. And the other gateways will just drop it. Now that might happen on the network server side. I'm not sure exactly who's controlling that. But yeah, if multiple gateways hear the same transmission, the one that gets the message loudest and clearest is the one that's going to pass it along, and everyone else is just going to forget that they heard it.
Got it. And so all of these gateways, let's say I have a ton of end nodes here, these gateways would now send their data to some network server, right?
Yep.
Like the activities, the laureates, things like that. So I'll go ahead and draw that activity. Senate, you mentioned, was one.
Yep.
I'll put laureate 2 here. But then you also mentioned it doesn't have to go to these guys, right? I can keep it directly on the gateway. So what would you call that, private or local?
Yeah, I'd call it private.
Private?
Private LoRa network.
Okay.
Yeah.
We'll do private. So we have our end nodes that are sending data to the gateways. It could be one, it could be multiple, and then the data goes from the gateway, it goes through a network. It doesn't have to be a public network, it could be like a private network if we want. So now I'm not passing my data to the cloud, it's just sitting on whatever network server I have. And then at this point, it would go to like a Cayenne, right? Okay, so, and at this point it would go to Cayenne. Now, we really haven't touched on Cayenne at all today, but there really is a need for an IoT project builder like this in this scenario, right?
There is.
Because I might have all of these end nodes communicating through my gateway, sending data through a network, but ultimately, how do I make that meaningful? What do I do with that data? So, can you talk a little bit about why there's a need for Cayenne, and maybe how has Cayenne integrated with some of these networks, or how is it making a splash in the LoRa space?
Yeah, well, I think you nailed it, Benny, in that what do I do with the data? You know, that's what Cayenne is solving at the end of the LoRa chain, because the data has been passed from end node to gateway to network server, and if the user were to just look at it, it would just be a string. It would just be this, string of numbers that doesn't have any meaning. So what Cayenne is providing, especially for the LoRa space, is okay, we're going to decode that data, and then we're going to assign it in a visual way to widgets where you can see, you can see your thermometer rise, you can see your soil moisture go up or down. And then you can now do something with that data where you're setting alerts and thresholds, saying, okay, well, if the soil moisture drops below a certain level, I want to know about that, or I want my sprinkler system to automatically turn on if soil moisture drops. So, just like any part in this chain, that application layer is super valuable because it gives the data meaning, gives it a context, and also now gives the end user something that they can do with it, actions that they can take. Probably 27.
Okay, so I'm sorry guys, I haven't really looked at the questions yet. I'm just gonna quickly, okay, so okay, I don't think there's any more questions that I'm seeing. Let me know if there is any view.
I'd like to say about getting started in the LoRa space.
Yeah,
since
please.
A lot of our viewers are developers, engineers.
Yeah.
So obviously, there's more research that you can do, but I think one of the, a good starting point, there are plenty of LoRa developer kits out there. Companies like Microchip and STMicro, they just make, they make the LoRa module that can go on top of, whatever device you're starting to build or prototype with, and you can start creating your LoRa device. They also have kits for building gateways. Unless you plan on getting into the gateway business, you just might want to acquire a low-cost gateway.
Yeah.
I know there's companies like Hacks IoT that literally make something that plugs into a Raspberry Pi that makes that Raspberry Pi a LoRa gateway.
A gateway.
Wow. And it's designed for testing, developer, prototyping. So yeah, you'd start with some sort of module, maybe some sort of kit. I know that companies like Microchip and ST, they have development boards, LoRa development boards, which are a little more feature-rich. If you didn't want to start from the chip up, you could start with a development board. And then as long as you have that, LoRa module on your device, and as long as you have that gateway to receive it, then you're ready to start getting to work. And then
you have to find a network server.
Then and it might be local. You might be sending just from the gateway, straight to Cayenne to do your prototyping. But we'll talk about that more in our docs section of Cayenne.
Got it.
And how to get your data out of what you're setting up and into our system.
Okay, cool. Well, we've reached, we're well over our 30-minute time. Sorry about the technical mishap that happened in the beginning, out of our control, but at this point I just expect it all. So if you stayed with us, thanks for staying with us. Sorry about the beginning. If you have any last questions, go ahead and answer them. Go ahead and ask them, and we'll be sure to answer them. And tune in next time. We'll probably be doing another LoRa video with one of our LoRa manufacturer partners to really get his insight, because he's really in the LoRa space. He's creating these devices, he's deploying networks, things like that. So thanks for tuning in, and if you haven't already, check out the Cayenne community. If you have questions, if you want to learn a little bit more about LoRa, check out the Cayenne documentation. We do have documentation on all of some of the most popular networks like Actility, Laureate, Senate, and have a good rest of your day. Is there anything else?
No, just thanks for having me on. It was great, and great questions.
Yeah. All right. See you guys. I got to figure out how to turn this thing off.